We're going to look at an example using the binomial probability distribution, and we're going to calculate the mean, standard deviation, variance, as well as minimum and maximum usual values for the situation. So here's our example. When a fair coin is tossed 50 times and the number of tails recorded, we want to find the mean, standard deviation, variance, and minimum and maximum usual values for the number of tails. So I've gone ahead and written our formulas here. The mean, this is mu, the symbol is mu, it's the Greek letter mu, is equal to n times the probability of a success. And in this case, the probability of a success is the probability of getting a tail. The standard deviation is the square root of n times p times q. The variance is sigma squared. So for the standard deviation and the variance, we have the Greek letter sigma. Standard deviation is just sigma. Variance is sigma squared is equal to n times p times q. And then our minimum and maximum usual values are the mean minus 2 standard deviations and the mean plus 2 standard deviations. So we're going to calculate each of these values. Go ahead and identify the elements that we need, though. For the first one, we need n and p. So n is the number of times that we're tossing this coin. So we're tossing it 50 times. So we have that n is equal to 50. Now, the probability of a success, that is the probability of getting a tail, is, with this fair coin, is 1 out of 2, or 0.5. And that's our p-value for our mean formula. I'll go ahead and write down what our q value is, because we'll need that as well. So q is equal to 1 minus p. And we just figured out what p is. So we have 1 minus 0.5, or q is also 0.5. So for our mean, mu, we have n times p. And we just plug in our values and do that calculation. So we have 50 times 0.5 in this case. And if we do that, we get 25 tails. Okay. So we'll go ahead and use the units correspond to what we're looking for here, and we're looking for the number of tails. So the next thing I'm going to go ahead and calculate is the variance. So the variance is sigma squared. That's that third formula that I've written down here. We'll go ahead and calculate the variance, and then we'll take the square root of that number and find the standard deviation. So the variance is this, not the square root. Let's undo that. The variance is n times p times q. Let me erase that here. Okay. So we have n, which is 50, times our p, which is 0.5, times our q, which is also 0.5. And so if we square that, we're going to get 12.5, and our units associated with that are tails, and we square those units, tails squared. So now for our standard deviation, which is sigma, it's the square root of that number. So the square root of n times p times q. So it's the square root of that 12.5 tails squared. And if we do that, we get approximately 3.54 tails. So that gives us our mean, our variance, which is sigma squared, our standard deviation, which is sigma. Now for our minimum usual value, so the minimum usual value, that is our mean minus 2 standard deviations. So if you plug in those values, the mean minus 2 times the standard deviation, that's going to give us approximately 17.93 tails. And then for our maximum usual value, we have the mean plus 2 standard deviations, and that's going to give us approximately 32.07 tails. So that's an example of the mean, variance, standard deviation, minimum and maximum usual values for a binomial distribution.